Greetings to you once again. Star e-learning platform welcomes you to a graph work lesson. This lesson is intended to assist Senior 3s and Senior 4 students and provide them with the necessary information and content that could help them perform better in science areas, especially biology, chemistry, and physics. So students doing chemistry, biology, and physics will benefit from this lesson much if at all they follow all the procedures and the content that is prepared in this lesson. Before we start our lesson today, I'd like to request you for one thing. That is, I would like you to support this channel by subscribing. Please press that subscribe button to support the channel. This channel needs your support. It needs your hand. So just tap on subscribe. By doing so, you would have done a great thing. Our YouTube channel is Star e-learning platform. Before you leave, after viewing and watching our presentations, I request you to subscribe. I want to thank you in advance because I believe you're going to do it. This is Teacher Kadu de Gracious. You can always ask questions about our lessons. You can comment. You can even make inquiries about our services. So use this telephone number. This number is connected on WhatsApp. You can always inbox us on WhatsApp. We shall be readily available to respond to you. I continue to ask you to subscribe. In our lesson today, we are going to look at graph plotting skills as I've already introduced it, and this is what we are going to study today. Under graph plotting skills, we are going to look at identifying dependent and independent variables. We are going to look at characteristics of a good graph. We are going to look at how to state a good title. We are going to look at how to label the axis. We are going to look at how to get a good scale. We are going to look at how to fill the axis with the results. And finally, we shall look at plotting the results. Now, straight away, let us begin by looking at the independent and the dependent variables. We want to look at how we can identify the independent and dependent variables. Of course, you know, in any given experiment, we always look at two related values, and they are the ones that we present in a graph. And since we are looking at graph plotting skills, we need to learn and know what independent and dependent variables are. So graphs that we always find either in theory exams or in practical exams, they show us the relationship between two related values, and those values are always either independent or dependent. They are dependent and independent. So all the graphs that we shall encounter, they are showing the relationship between independent and dependent values. So what do we mean by dependent and independent values? Let us start by looking at the independent values. So independent values in this case, they are values that cause an effect to the dependent values. For example, time affects the distance covered by an object. Hope we all know that if an object is moving, the time it takes in moving, it will determine a lot the distance that object will cover. So time is now the determinant. The time is now the determinant. In other words, time is now an independent variable. Reason being, it determines how much distance can be covered in a given time. Or during movement, it can tell us that as an object is moving, the time it takes can always predict what time it can, what distance it can cover. Hope I'm clear there. Now, what are dependent variables? Dependent variables are just those values whose change is caused by the independent values. For example, distance covered by an object can depend on the time that is taken to cover that distance. As I've already expressed it, as an object is moving, the time it takes in moving will determine how much distance it will cover. So therefore, time is an independent variable because it determines how much distance is covered. So time is an independent variable, while distance is a dependent variable. So in other words, distance depends on time. Okay, let's continue. Now, after looking at that, we can summarize that concept we have just seen and say that dependent values or variables, they are a cause. Sorry, independent values or variables, they are a cause. I repeat, independent values or variables, they are a cause. In this case, time is a cause because it causes change in distance. When distance is to change, time must be considered because as an object is moving, the time it takes while moving will determine how much time, how much distance that object will cover. So time is an independent variable. Reason being, it causes change in distance. Now, a dependent variable on this side, or on the other hand, a dependent variable is an effect. The effect caused by the independent variable is now the dependent variable, and it is that effect in this case is the distance. The distance an object covers, that is now the dependent variable. In simple words, independent variables are the cause, while dependent variables are the effect. So whenever you're looking at values or you're looking at graphs, you should know which one is the cause and which one is the effect. Now let us look at this from the biological point of view. Now let us look at these pictures. We have plant 1 and we have plant 2. In plant 1, we are adding a lot of water. Much water was added to plant 1, while plant 2 received little water. What's the effect of adding much water? The effect of adding much water is going to be seen after some few weeks. For example, if you look at plant 1, in plant 1, this plant is going to increase in height. It is going to grow taller in height. Even it may increase the number of leaves after a certain period. So plant 1 is responding to the amount of water that was added by increasing in height. Remember, they are the same plants, they are the same kind of plant, but they are responding differently. When we look at plant 2, where we added little water, it is remaining stunted after some few weeks. It is remaining stunted, which means the amount of water which was added affected these plants differently, and therefore they also responded differently. So the cause of the change in the growth rate of these plants, because of course water is going to affect the growth rate of these plants. This one is growing faster, while this one is growing slower, or not even growing because there is little water that was received by that plant. So this plant is responding by growing taller, while this one remained stunted after some few weeks. So in this case, let us go back to independent variable and dependent variables. We are saying that independent variables, they are always changed, while dependent variables, they are affected by the change. In this case, water is changed. Here, we added a lot of water. We added enough water. We changed that water and we added little on plant 2. Now, changing the water affected also the change in the size of the plant. It affected the change in the size of the plant. So when we added this water, it affected the change in the size of the plant. So that's why this one is growing taller while this one is remaining stunted. Hope you get me there. So in simple terms, an independent variable is a variable that is changed, and a dependent variable is a variable that is affected by the change. Hope you get me here. So in conclusion, we can say that amount of water added is an independent variable, while the size of the plant or the number of leaves is now the dependent variable. Hope you get that point clear. Now, in biology, I repeat, in biology, you will see that what you decided to do in an experiment, in fact, not even in biology, but in all subjects, in all science subjects, what you decided to do as an experimenter is an independent variable. The effect of the action you do or what you decided to do is now the dependent variable. I repeat, what you decided to do in an experiment, either physics, biology, or chemistry, what you do is now an independent variable. The effect of that decision you take to do the experiment is now your dependent variable. In this case, we decided to change the amount of water. So we had decision on how much water we are going to use on each plant. So that water now became our independent variable. Now the response to that change, or the response to that action, which is now change in size of the plant or change in the number of leaves, is now the dependent variable. So you've got me there. What you decided to do is an independent variable. The response to that decision you've taken, or that action you have done, it is now the dependent variable. Hope you get me there. Let's proceed. Now let us try to sum up dependent and independent variable by looking at this. Now we have already looked at an example, and we said that if we change the amount of water that a plant receives, the height of the plant is going to change. So the independent variable in this case is water, because water was changing. We are changing the water. We are deciding on how much water is to be added. So we are changing the water. So in this case, the dependent variable was the height of the plant, or change in size of the plant, because it was affected by the water. So the plant responded by, these two plants responded differently. One grew taller while the other one remained stunted. So that response, which is now the height of the plant, is now the dependent variable. Hope you get me there. Okay. Now, after looking at what dependent and independent variables are, we are now good to look at characteristics of a good graph. Now, any graph to be called good, it must have these 5 characteristics. These 5 characteristics are summarized in one word, that is TASIPS, where T is standing for title, T is standing for the title, A is standing for the axis, S is standing for the scale, P is standing for the plottings, and size is standing, S is standing for size. Hope you get me there. We have looked at title a bit by looking at the dependent and the independent variable, but we are going to look at it in details. Now let us look at how to state a good title. If you are to state a good title, we should then be able to identify the dependent, that is the effect, and the independent, that is the cause. So we should be able to identify the independent and the dependent variables if we are to state a good title. The dependent variable, in this case, if you are to state or write a good title, the dependent variable is always written first. We write the dependent variable first, followed by either of these words. You can either use the words varying with, or you can use the word against, or versus. Hope you're getting me there. And this title should always be written in capital letters and underlined at the top of the graph paper. Of course, they provide us with graph papers. So follow those steps and write a good title. You write the dependent variable first. You join that dependent variable with either of these words, either varying with, against, or versus, but in capital letters, and also underline it at the top of your graph paper. One thing we should also note, we should also include the units for each of the variable given to us. You should include the units for dependent variable and the units for the independent variable. So the units should be included. Hope I'm clear there. Okay, now there's a very serious note I want to make here. Now, since we are dealing with the variables, we shall always use the word varying with if we are looking at biology. I repeat, if you are dealing with biological graphs, the word varying with is better to use. All those words varying with, they are better to use. If at all the examiner have not provided you a question on which you will best write your title, he's just telling you to get a title of your own choice, then the best words to join your dependent variable with the dependent variable is that word varying with. So always use that word varying with. Like for example, if we come to our biological point of view, where we looked at the two plants receiving different amounts of water, how shall we write a title if this is an experiment? Now, if this is an experiment, we should determine which one is a dependent variable. The dependent variable in this case is the size of the plant or the number of leaves. So those variables represent the dependent variable, and the independent variables are these. So if we are to write a title for such an experiment like this one, we shall say a graph of size of a plant varying with the amount of water added. Or you can say a graph of number of leaves varying with the amount of water added. So that's how we can simply state the title. You write the dependent variable first, followed by the independent variable, and you must join the two words with the word varying with, the words varying with. So if you do that, that title is going to be very correct. If there are units, you must also include those units. Okay, let's continue. Let's continue. Okay, here we are. So hope that point is clear to you. Now let's move on. Now let us consider this table of results. We want to use it to form a title for our graph. We want to use this table of results to form a title for our graph. When you look at these results, in fact, in all experiments we make, we must come up with a table of results like this one. So we must come up with a table of results, and we might be required to plot those results in a graph. So sometimes we can get the title of a graph from the question given to us. If the question is not provided, then you can follow the procedures that I've given you and you write a good title. You identify the dependent variable and the independent variable. You write your title and you join the dependent with the words we saw. But there's now one thing here we need to note. Now, they have given us a question. They want us to plot a graph of temperature change against the volume of BA1. But there is something this question is not giving us. This question has not given us the units for the dependent and the independent variables. So using our table of results, we can look at the units that are used and we apply them when we are writing a title. Like for example, temperature change, the units are degrees Celsius. If there are expressions, the expression should also be included. So our expression is dt and the units are degrees Celsius. Hope you're together. When we look at the volume of BA1 used, the units are cubic centimeters and there is BA1. So don't just say volume of solution or volume and you say cubic centimeter. You even mention the expressions that are given to you. So in this case, let us see how the title is going to look like. Now, we said we write a graph of, we first write the dependent variable. In this case, the dependent variable is temperature change. It is expressed as dt. The units for temperature change, degrees Celsius. Then we join the two variables with the word against. We are using the word against because it is included in our question. So that's why we are using it. So the independent variable in this case is the volume of BA1, and the units are cubic centimeters. So after doing as above, then it means we have written now a very correct title for our graph. Now we can do the rest. However, any graph, however good a graph would be, but so long as it has no title, that graph is meaningless. So before you go on with the plotting, scale, and whatever, the first thing you should do, write the title in capital letters, include the expressions, include the units, and underline that title at the top of your graph. By doing that, now whatever you're going to do down here, it is going to be considered because it has a title, but they will not consider anything you put here if the title is not there. So never forget writing the title. Hope you've got me there. Let's continue. Now, after looking at how we write a title, now let us look at how to label the axis. We are going to use these two words, that is dry mix. We're going to use dry mix. Dry is just an abbreviation where it is telling us these three concepts: that dependent variables that respond to the change, they are plotted on the y-axis. Remember, we said when we are talking about dependent variables, we said they respond to the change. They respond maybe in a different way, as we have seen. So dependent variables that respond to the change are plotted on the y-axis. The y-axis in this case is that vertical axis. That is the y-axis. Okay, so let us go to this word mix. What does mix mean in our concept here? Mix. Mix here, M is standing for manipulated results that cause change, which are independent variables. Which are independent variables. Independent variables. They are plotted on the x-axis, as you see there. So we come to the word mix. So always, if you are to remember, use the word dry mix. Dependent variables that respond to the change, they are plotted on the y-axis, while the manipulated results that cause a change, and they are called independent variables, they are plotted on the x-axis. The other ones, dry, they are plotted on the y-axis. So dependent variable that respond to the change are plotted on the y-axis, while manipulated results that cause change and are called independent variables, they are plotted on the x-axis. Hope that is clear. Let's continue. Now, at this time, after learning what we can do, now dependent variables go on our y-axis. So temperature change is a dependent variable. Don't forget to write the expression for temperature. Don't forget to write the units for temperature on your on the y-axis. On your y-axis. Now the reason why we include the units, remember, we are going to put values here in this space here. But in these values, since it is temperature, that temperature is already going to be represented in degrees Celsius. Hope you're together. So every value you write here, you don't need to write degrees Celsius. You'll just state the value in this space here. There's no need to include the units. So the units are already included in the axis. The units are already included in the axis. They are already here. So as we write here, we don't need to repeat that. However, if you forget to write those units, everything you write here may be useless. So if there are units specified in your table, try to include those units, because you will not be able to write all the units here. You will not be able to write units here. Include the results there with the units. The units are just going to be expressed and summarized and written here. Okay, the same applies to the x-axis. Hope you get me there. So every unit that will go here, it will be in cubic centimeters. So there is no need to repeat it. So labeling the axis, you must include the expression and also include the units. Don't forget to write the units. Let's continue. Now let us look at how to get a good scale. We want to look at how to get a good scale. There are steps we follow. Of course, we get our scale from the table of results. Assuming you have done your experiment or they have provided you with the results in an exam and your results look like this. They look like these ones in this table. And they want you to represent these results in a table. There's nothing you can do before you have got before you have got a scale. You need to get a scale. We need to get a what? A scale. Okay, so let us consider these results and we use them to plot or to make our scale, then followed by plotting. Now we have a question. After our results, we are having a question here. They are telling us to plot a graph of temperature change against volume of BA1 used. They want us to plot that graph. So what is required here? Let us see. Now, before we think of making a scale for ourselves, there is something we need to focus on or to look at before even we think of getting a scale. Now, we should already think of the size of the graph we are going to use. The size of the graph we use here should be at least big enough. It should be big enough. So therefore, we must ensure that we use the largest space possible. In fact, in most cases, we use 3/4 of the graph or more, but don't use less than that. So make sure your graph is large enough. So if your graph is large enough, the plottings are going to be visible. They will be visible and not crowded. Now, in doing that, there are things we are going to do to ensure that our graph is large or big enough. First of all, we shall leave a centimeter above here. Leave 1 centimeter at the top of your graph. Leave that centimeter. That centimeter up here, it is going to help you to write the scale. You'll use it to write the scale for your graph. So we shall use that space to write the scale. Also, leave 1 centimeter this side here. If you leave that 1 centimeter this side, that is space, we are going to use it to write the values for the y-axis. Also, leave 1 centimeter down here, or leave some space down there. That space is going to help you to write the values for the x-axis. Hope you get me there. Okay, so after doing as I have shown you, now you can go ahead and measure the distance which you are going to use, or the length of the axis that you are going to use. So in this case, on the y-axis, we have decided to use 80 centimeters. So we are going to measure 8 centimeters from here up to here. So that space there, it is going to be 80 centimeters. We are using the largest space possible. We want to get a good graph, a large graph that is visible and not crowded. So we shall measure 8 centimeters on the y-axis, and on the x-axis, we are going to measure 6 centimeters from here up to here. And we measure 60 centimeters. Hope you get me there. Now we have determined, or we have decided which length of the axis that we are going to use. When you look at our graph, we have decided to use the largest part of the graph paper that is provided to us. We have decided to use the largest part of the graph paper. Let's continue. Now, we have done as we have seen. The next step we are going to do here, remember we are developing a scale. We are looking at the steps on how we can develop a good scale. Now we can analyze our table of results. Analyze your table of results. Why do we analyze the table of results? We do it for one reason. We want to identify the lowest values and the highest values in the table. Let's look at that table. Let's look at that table. Okay, the table is here. They told us that we are supposed to analyze. Okay, let's try to analyze this table of results. Let us begin with the y-axis, that is temperature change, dt, in degrees Celsius. The smallest value here, it is 1.4 degrees Celsius. And the highest value here, it is 6.8 degrees Celsius. Let's move on to the x-axis. On the x-axis, we have volume of BA1 used, that is in cubic centimeters. The smallest value here, it is 5.00 cubic centimeters. And the highest value here, it is 40.00 cubic centimeters. So let us see how we are going to use these results in developing our scale. Let's try to continue. Of course, as I've already shown you, we are to plot temperature change on the y-axis and the volume of BA1 on the x-axis, as we have already seen. So the highest value for temperature change, it is 6.8 degrees Celsius. According to our table, it is 6.8 degrees Celsius, while the smallest value is 1.4 degrees Celsius. And the highest value for volume of BA1 used is 40 cubic centimeters. That is the highest value for volume of BA1 that was used, while the smallest value for volume of BA1 that was used is 5 cubic centimeters. So let us see how we are going to use these highest and smallest values to develop a scale. Let us start with the y-axis. We want to start with the y-axis. Now, starting with the y-axis, we know our highest value, it is 6.8. We are going to choose a small number. Choose a small number. That number should be small. At least it should be less than your lowest value. That number should be less than your lowest value. Our lowest value or smallest value, it is 1.4. So choosing 1 is okay because it is less than 1.4. So that number we have chosen, and in fact that number we choose, we shouldn't choose big numbers. We shouldn't choose big numbers. We should choose small ones. Okay, that one we have seen it. So now we are going to get that small number and add it to our highest number. So therefore we shall have 1 plus 6.8 and we get 7.8. We shall still get this small number we have chosen, which is 1, and subtract it from our smallest number or value. We shall end up getting 0.4. Now we are going to write our highest value, which we have obtained, which is 7.8. We are going to write it at the maximum centimeters that we are going to use on the y-axis. So the centimeters we are going to use on the y-axis, that is 80 centimeters. So we shall write 7.8 at 80 centimeters mark on the y-axis. Hope you get me there. We shall write our smallest value that we have got, that is 0.4. We shall write it at the start of our y-axis, that is at 0 centimeters. Hope you get me there. Let's proceed. Okay, so this is what we have done. Our graph will look like this. So we have written our highest value at the 8 centimeters mark and our smallest value at the start of the graph. Hope you know that our graph measured 80 centimeters. it measured 80 centimeters. We measured 8 centimeters on the y-axis. So we shall write 7.8 at the 8 centimeters mark at that point. And we shall write 0.4 at our lowest mark, that is 0 centimeters at this point here, at the start of the graph. Hope I'm clear there. Okay, fine. Let's continue. Now let us try to look at the x-axis. We are going to do the same on the x-axis. We shall choose a small number or a small value, and that small number or value should be less than our smallest value. Our smallest value in this case, it was 5. So choosing 2 is okay. It must be smaller than the smallest value. So we have chosen 2. If you try to subtract 2 from 5, we get 3. We do as we have done on the y-axis. If you try to add a 2 on the highest value for the x-axis, we get 42. So therefore, our highest value after adding a 2 on the x-axis becomes 42. While our smallest value after subtracting a 2 is 3. So therefore, we are going to write our highest value, the one we have got, that is 42, at the maximum centimeters that we are going to use, and the centimeters on the x-axis that we measured 60 centimeters. So we are going to write 42 at the 60 centimeters mark on the x-axis. We shall also write our smallest value that we have got, that is 3, at the start of our x-axis, that is at 0 centimeters mark. Hope I'm clear there. Let us see how this graph is going to look like. So at this point, this graph is going to look like this. For the y-axis, we have written our values there. For the x-axis, after subtracting our smallest value, that was 2, we have got 3. Then, after adding a 2 on our highest value, we have got 42. Now, there's a reason for doing this. Why should we do this? The reason is simple. The reason why we do this, we want to get what we call a limit. We want to get a limit for our values. In other words, if you look at the y-axis, the values that are going to go here, the values that we shall plot there, the values that we are going to plot in this, the values that we are going to write in this space here, the values that we shall write in this space here, the one we left this space here, they shouldn't go beyond 7.8, and they should not go below 0.4. So the reason of doing as we have done before is to get a limit. Now we have got a limit of the values that we are going to enter here. They should not go beyond 7.8 and not below 0.4. Hope I'm clear. Similarly, on the x-axis, the values that we have put here, they should not go beyond 42, and they should not go below 3. So we have got our limit. So we are very close to getting a scale. Let's continue. Now, let us look at how to get a scale, or getting the scale. What are we going to do next? We are going to subtract the smallest values that we obtained after adding our number that we have chosen. Those smallest values, after subtracting the small numbers that we chose. So on the x-axis, we got a 3. We subtracted a 2, and we got 3. On the y-axis, our smallest number, we subtracted the 1, and we got 0.4. So those are the values we got, and we have already written them on our axis. On the x-axis, we have written 3 as our smallest number at the start of that x-axis. On the x-axis, we have this. We have 3. While on the y-axis, we have 0.3 at the start of the y-axis. Hope I'm clear there. Okay, so now as we said, we must subtract the smallest values from the highest values. If we do so on the y-axis, we are going to get 7.8 minus 0.4, and we get 7.4. For the x-axis, we are going to get 42 minus 3, and we get 39. Hope I'm clear there. Now, why do we do that? Why do we do all that? Let me try to explain a bit. The reason for doing that, we want to get a range, or we want to get the values that are within the distance that we measured. How many centimeters did we measure here? Here. How many centimeters did we measure? Hope you remember, we measured 80 centimeters on the y-axis. So we have subtracted this one from this one, and we got 30. Sorry, I beg your pardon. We have subtracted this one, 0.4, from 7.8, and we got 7.4. Therefore, it is 7.4 degrees Celsius, because on the y-axis, we have units, degrees Celsius. And remember, the distance we measured here is 8. So this value we have got here, 7.4, that value there, it is giving us a total of the values that are going to go here. The values we are going to write here, they are going to be totaling to 7.4. Hope I'm clear there. Which means that the 8 centimeters we measured here, the 8 centimeters that we measured here, 8 centimeters, they contain 7.4 degrees Celsius. Hope I'm clear there. Now, when you look at our table of results, we have many results. There are many, more than 5. So this is just a presentation at this point here, at that point there. But we have many values. Which many values we must distribute them in our graph. So we are going to distribute our values per every centimeter. Per every centimeter. So if 8 centimeters represent 7.4 degrees Celsius, then what about 1 centimeter? 1 centimeter will represent 1 times 7.4 divided by 8. Hope you're together. You've known how we have got this. You've known why I'm using 8. So we come to this. Is it okay? Okay, let's continue. Now, if we come back here, they have told us that divide the answers we have got, for example, 7.4, divide the answers we have got with the centimeters that we are going to use. After dividing 7.4 divided by 8, this one here, we are going to get 0.92. So that one becomes our scale. In simple terms, we are near to the scale. In fact, we have got the scale. We only need to express it better. When we go to the x-axis, let us try to look at that on the x-axis. On the x-axis, how many centimeters did we measure here? We measured 6 centimeters. Hope you remember. What is the difference we have got after subtracting this one from this? What have we got? We have got 39 cubic centimeters. So which means the 39 difference or cubic centimeters that we have got here, they are the cubic centimeters that are going to be at this area here. The values that we are going to plot in this area here, they are going to be totaling to 39 cubic centimeters. So which means the 6 centimeters, the ones we measured, contain 39 cubic centimeters. So the 6 centimeters that we measured, this one, they are going to be containing 39 cubic centimeters. But as I said before, there are many results in our table. So we need to find them spaces where we are going to distribute them. So therefore, we should think of using centimeters. We should think of using 1 centimeter, distribute them per centimeter. So if 39 cubic centimeters contain in 6 centimeters, what about 1 centimeter? 1 centimeter is going to be, we shall have 1 times 39 divided by 6. Hope you get me there. So what we shall get here is going to become our scale. Hope I'm clear. Let's continue. Now when we did as we have already done, we are going to get 6.5 on the x-axis. So which means 1 centimeter represents 6.5 on the x-axis. Then on the y-axis, 1 centimeter represents 0.925 degrees Celsius. Okay, let's continue. Now we have come to what we call a scale. We have got the values that are within 1 centimeter. So 1 centimeter in this case represents 0.925 degrees Celsius. Include the units. Don't forget to put the units. If we say vertical scale, a vertical scale is the same as the y-axis. Horizontal scale is the same as the x-axis. So on the horizontal scale, 1 centimeter represents 6.5 cubic centimeters. Hope I'm clear. Let's continue. So at this stage, we can smartly write our title at the space above here. This space we left for writing the scale, that is where we are going to write our scale. We shall write our scale smartly like that. So our vertical scale, or the y-axis scale, we have 1 centimeter representing 0.925 degrees Celsius. Hope I'm clear. Then on the horizontal scale, we have 1 centimeter representing 6.5 cubic centimeters. Hope I'm clear there. So our scale is smartly written like that. So getting our scale, now we are pushing to now plotting. Because after getting the scale, plotting is going to become very easy. But remember all the processes or the steps we have gone through when developing a scale. They are all necessary. Let's continue. Okay, now we are going to this bit. We want to fill the axis. We want to fill the axis with results using our scale. What are we going to do? We are going to add the scale interval to the smallest value, the smallest value, to get the next value on our axis. We shall continue adding until we fill our axis to the highest value. Then we shall do the same on the other axis. Our highest value should match with the one we marked when getting the scale. So our highest value should match with the one that we marked when getting the scale. And we should also avoid unnecessary approximation because it will change our scale. So those points that I've noted there are very important, as we are going to see. Okay, let us look at this graph a bit. Here we are. Let us see how they got these results. We are having those results distributed on the axis. We have said get the smallest value. On the y-axis, our smallest value is 0.4. That is the smallest value that we wrote after the processes we went through. We got 0.4 on the y-axis. So we are saying add our scale interval. Our scale interval on the y-axis is 0.925. We are saying add the smallest value, which is 0.4. If you add it, we are going to get 1.325, that value there. If you look at your scale, that is going to be now your next value, which is this one. Hope we are together. If you want the next value, you continue. So we have stopped on 1.325. Continue adding. We are going to add 0.925. If you try to add, we are going to get 2.25. We shall get 2.25. Hope I'm clear there. So you come and write it here. If you want another value, just add 0.925 plus 2.250. What do you get? We are going to get 3.175. Hope I'm clear there. So you go on adding your scale interval, which is 0.925. You go on adding until you reach this value here. We should always avoid unnecessary approximation because it can change our scale. And there's only one way we can do this. To avoid unnecessary approximation, we can always write our values with some more decimal places. We are supposed to write here, we got 7.8. But for us, we have written 7.800. Why have written with the 3 decimal places? We have written with 3 decimal places to cater for the unnecessary approximation. So if we are to approximate, we shall only do it on the last digit here. We shall only do it there. So we would have avoided that unnecessary approximation that would affect our scale. So that's what we have done. So we have written our digits with the 3 decimal places, our values with the 3 decimal places to cater for the unnecessary approximation. Because if I get 6.875 maybe 8, I will only have to round off the 5 and I make it 6.876. Hope you get me there. So you see, this value here is not affected. The 0.87 is not affected because my approximation is only done between the 8 and the 5. Hope I'm clear there. So if I write my values with 3 decimal places like this one, they are going to help me avoid unnecessary approximation, and therefore my scale will not be affected in one way or the other. However, if your values are not having many points, you may even use 1 decimal place if they are not having many points. But if your values are having many points, better use at least 3 decimal places or 2 decimal places to cater for the approximation. Hope that is clear. So when we look at the x-axis, we said our beginning value is 3. So if you want to write the next value, we shall just have 3 plus our scale interval is 6.5, that is plus 6.5. If you try to add, we are going to get 9.5. So we come and write our 9.5 at 1 centimeter mark. That first centimeter, we shall write 9.5. If you want the second value, you continue adding. So what shall we do? We shall have 9.5 plus 6.5. If you try to add, we are going to get 16. And that is your value there. Hope you get me there. If you want the third one, you do the same. You get 6.5, our scale interval, plus the 9 point, oh, I beg your pardon, you get the 6.5 plus 16. What do we get? We shall get 22.5. We shall get that. So simple like that. So you write all your values until when you reach this value here, and the maximum value you get should not be beyond 42. Similarly, on the y-axis, your maximum value should not go beyond 7.8, as we have already said. Let's continue. Okay, so we have seen this. And I've explained how this one comes about and how we feel the access with the results using our scale. I've shown you how it is done. Hope that point is clear to you. Let's continue. Let's continue. We have seen that. Now, what is our next step? Our next step in this case is now plotting, because after distributing your results and showing how your results are going to appear, then the next step or the final step is now plotting in the graph. We are going to start with a pair of the smallest values in our table, because in our table we had smallest values starting the table. We had those smallest values that we are starting the table. However, in other tables, you may see that on the x-axis you may have a high value or a highest value, and then on the y-axis you have a small value. So in this case, it was having small values starting the table. So we are going to start with that pair of the smallest values. So we plot values in pairs. Those values that are contrasting or are matching together are the ones we shall plot at every time. And make sure you don't jump. You plot one, you go to another, you go to another until you finish all the results in pairs, the x and the y, as we are going to see. Now, as we are starting with a pair of the smallest values, we are going to divide the values with their respective scale intervals. Hope that one is seen. After doing that, we shall subtract the centimeters that represent the first values. Okay, let's look at this. Let's try to look at this. Now, when we look at our graph here, let us try to look at our graph. Our graph does not start from 0. On the y-axis, it starts from 0.4. On the x-axis, it starts from 3. So, since the graph is not starting from 0, it means those values that we have, for example, 0.4, they are representing a certain length or a certain number of centimeters we don't know. So we need first to know the number of centimeters that are representing the 0.4 using our scale. So on the y-axis, our scale is telling us that we have 1 centimeter representing 0.925. That is on the y-axis. Then what about the 0.4? It will be represented by how many centimeters? We shall cross multiply 0.4 times 1 divided by 0.925. Hope I'm clear. We have started with the y-axis. Let us see what we get here. Let us see what we get. Let us start with the y-axis. If you try to calculate, we have said on the y-axis we are having 0.4 starting the graph, but we want to know how many centimeters are represented by the 0.4. So we use our scale. 1 centimeter represents 0.925 degrees Celsius. Then what about the 0.4? It is a matter of cross multiplying, then we divide. If we do so, we come to that. So which means 0.4 centimeters represent 0.4 degrees Celsius. So which means every value that we are going to enter on the y-axis, we must subtract this centimeters. We must subtract 0.4 centimeters. Let us see how this one is going to be done. Okay. So our graph is here. Our graph is here. We have said every value that we are going to plot on the y-axis, we must subtract 0.4 centimeters, because 0.4 that starts our y-axis, the 0.4 degrees Celsius, they are represented by 0.4 centimeters. Hope you have seen that. So here, that is 0.4 is representing 0.4 centimeters on the y-axis. Let us look at that on the x-axis before we begin the plotting. Let us first look at that on the x-axis. Then we shall start with the plotting. On the x-axis, we have our scale interval as 6.5. So which means 1 centimeter on the x-axis represents 6.5 cubic centimeters. Then what about the 3 cubic centimeters that start our x-axis? It's a matter of cross multiplying. We come to this. When we compute, we come to 0.5. Therefore, 0.5 represent 3 cubic centimeters. Let's look at that graph. So we have said on the x-axis, 1 centimeter represents 6.5 cubic centimeters represents that. Then what about the value here that starts our x-axis? That is 3 cubic centimeters. They are represented by how many centimeters? So we shall have 3 times 1 divided by 6.5. For our case, we have got 0.5 centimeters. We have got that, which means 0.3 represents 0.3 cubic centimeters. They are represented by 0.5 centimeters. So which means every value that we are going to plot in the x-axis here, every value that we shall have to plot using the x-axis, we must subtract 0.5 centimeters. Hope that is clear. Let's continue. Let us see how this one is going to be done. Now let us go into the plotting in the graph using the scale, and also considering the values that start our graphs. Let us start with the x-axis. On the x-axis, the value that we are going to plot, we want to plot 5. Let us try to look at our table. Look at our table. Our table is there. The table we have, we are going to plot 5. We shall plot 5 with 1.4. So 5 on the x-axis, that is for the volume of BA1, and 1.4 for the temperature change on the y-axis. On the x-axis, volume of BA1, on the y-axis, temperature change. Okay, let us see how this is going to be done. Okay, what we are going to do, as we said, in our table of results, we are going to plot 5 to find the location of 5. We want to find the location of 5. What shall we do? We shall have to divide 5 divided by our scalar interval, which is 6.5. If we do so, we get 0.80 centimeters. What we shall do next, we shall have to subtract the centimeters that are represented by the first value on the x-axis. That those centimeters we calculated is 0.5, and we said 0.5 represented the 3 centimeters that start our graph. If you try to subtract 0.5 from 0.8, we get 0.3 centimeters. So what shall we do? We are going to measure 0.3 centimeters on the x-axis, and we mark that point with a pencil. Hope you're together. Let's continue. So after doing as we have done, now our point, the 5 cubic centimeters are located at 0.3 centimeters. So mark that point with a pencil. So that point, it is measuring 0.3. It is from here up to there. It is 0.3 centimeters. That point is having the 5 cubic centimeters. Hope you get me there. Let's proceed. Let's proceed on the y-axis. We look at the y-axis. On the y-axis, we are going to plot 1.4. What shall we do? We are going to divide 1.4 with the hour scalar interval, which is 0.925. If we do so, we get 1.5 centimeters. Now what we are going to do next, we are going to subtract the centimeters that represent the first value on the y-axis. And that those centimeters that represent the first value are 0.4 centimeters. So we shall have 0.4 minus 1.5, and we get 1.1. Now we are going to measure 1.1 on the y-axis, and we mark that point with a pencil. Hope we are together. Let's continue. Now at this point, this is the mark we have made. We have measured a distance from here up to there. That distance is 1.1 on the y-axis. So we have now made 2 points, one for y-axis and another for the x-axis. Let us see how we plot our value. So we are now on the finishing line. What are we going to do? We are going to join the 2 points with either of the following markings. You can use a ruler and a pencil. You join the 2 lines, or you join the 2 points. What do? You can join the 2 points with a point and a circle around. That circle must be small. A point and a circle, or we can use a cross and a circle around. So where the 2 points meet, that is where you put these points. So for this case, we are going to use this one. We are going to use a point and a circle. So if we do so, this is what we are going to get. So at that point, we have marked the distance covered by the 5 cubic centimeters. So this is 0.3. Of course, 0.3, it is having, we calculated for the x-axis. Hope you remember. We calculated and we said the 3 centimeter represent 0 point, or they are represented by 0.5 centimeters. Then that is for the 3 cubic centimeters. Then we calculated a total of 0.8. So which means this distance we have measured, the 0.3 centimeters. It means that distance now is representing 2 cubic centimeters. When you add, you have 5, representing 0.8. So for us, we have measured 0.3 from this point here up to a certain point where the two are meeting. So we have measured 0.3. When we measure 0.3 and we add it to the 0.5, which is represented by the 3, we end up getting 0.80 centimeters. So we shall not measure the 0.5 because it is already covered. We shall only measure the remaining distance, which is 0.3. So that is what we have measured for the 5 cubic centimeters, and its location is at that point. On the y-axis, we already had 0.4 centimeters, representing the 0.4. Hope we are together there. Then, for this case, we have measured how many centimeters? We have measured 1 point. In fact, we measured 1.5. But for this case, we have measured 1.1 centimeters. 1.1 here, it is going to be representing the 1 degree Celsius. So that if you try to add here, you get the 1.5, 1.5 and 1.4. Remember, we have been plotting 1.4, our first value. We have been plotting 1.4. According to our graph, the 0.4 is already covered by the 0.4 degrees Celsius. This one, it is already covered by the 0.4 degrees Celsius. So it is a matter of measuring the remaining distance. So the remaining distance here is 1.1 to make it 1.5. Hope you remember what we did when we are developing a scale. I hope that is clear to you. So 0.3 centimeters, they are showing the remaining distance from the 3, which is here. The remaining distance to make 5 is 0.3. That is on the x-axis. While the remaining distance to cover the 1.4 on the y-axis, it is 1.1. That is on the y-axis. So we shall just measure that remaining distance that is going to complete the value that we have got, or the value that we are trying to plot. Hope that's clear. Let's continue. Now, some students may plot only one plot, and maybe time catches them. So at this point, you qualify to get marks. For the title, you get marks for the scale, you get marks for the axis, and for that one plot. However, if you do everything and you forget to plot, you don't qualify to get any mark. They don't give you any mark. You only get marks after at least making one plot like this. So after making one plot, you qualify to get marks on the title, on the axis, and even on that plot. However, every plot that you make scores you a mark. Every plot that you make scores you a mark. So therefore, ensure that you plot all the values and get the full marks that are assigned to that graph. Okay, let us see. Now we are going to follow the same procedures as before, and we plot all our values in the graph, and it will look like this. If you try to plot, that graph is going to look like that. So after plotting all your values, then you should analyze your graph. Look at the plottings. Are they in a straight line or they are making a curve? If they are in a straight line like these ones, we shall join those plottings with a ruler. We draw a straight line using a ruler and we join those plots. And we should make sure all the plottings are falling on our line. Or if not, a few can be left out. But we should ensure that all the plottings are falling on our line. So here since they are lying in a straight line, then we shall have to look at using a ruler, as we are going to see. However, if your plottings are in a curve form, for example, you have got plottings and they are appearing like this. They are appearing like this. They are like that. They are not in a straight line and they are distributed like that. Then you have to join those points with your free hand. Get your pencil and join the points with your free hand, just like that. So that is now a curve, which curve is drawn using your free hand. So I think this curve is different from this. This one is made up of plotted points that are in a straight line, while these ones, they are not in a straight line. Let's continue. So you're going to follow what I've already explained it to you. If your plottings are in a straight line, then join most of the plotted points with a ruler to form a line of best fit, as shown in the graph that we are going to see. And we should make sure no point of your points are left out. However, if the plotted points form a curve, then join all the values with our free hand, as I have already shown you. Now, let us see how our graph is going to look like. For this case, our graph is going to look like this. We are going to draw a straight line this side here and a straight line this side here. So that graph is going to look like that. So we shall get all the plottings. We shall get marks for all the plottings. We shall get marks for the title, for the scale, and the axis. Okay. I think I've presented all that I had prepared to present to you today. I want to thank you for viewing our lessons and watching our presentations. May the Lord bless you. We meet in the next lesson.